We're about to kick it off for CYC 2025. That's why you are here. And then I should be able to point this here. And then I got this. I got two cameras. Life is good. How we feeling? Yeah! Penultimate talk of the day. Here we go. You are here for Data Gone in 60 Seconds, a serverless ETL story. So here's the story so far. Let's just get right into it. I love serverless. If you like serverless, make some noise. Okay, great, good, perfect. So that means I get to talk about the fun stuff, which is the terrible stuff that you have to deal with when you're building things. How to overcome this terror of having to build something with divine inspiration from the one true God of the internet, Nicolas Cage, and we will get to that. And just remember that all software is just a journey of trade-offs. Everybody here made a case for a trade-off they had to make. Every single talk is just that. So we'll start with there. Of course, we have to start with the business, because you got to talk to business in order to build software. So imagine you're going to a meeting with a holder full of steaks, and what does business want? You come in with your notepad. You're not exactly sure. It's about to kick off. And you learn you're going to build a data pipeline. You're like, cool, I love data pipelines. I build data pipelines all the time. You're not going to be able to control what data comes in. Okay. And then you have to actually do stuff to it. Okay. We want it in real time. Like real time? Like near real time. I'm like, okay. And I need you to store it in an external data lake that's outside of our network too, because it's going into another BI system somewhere else. So you're like, okay, what am I actually doing then? So once you're in that meeting with stakeholders, then you realize you have constraints. The data is coming out of like, you can imagine like an IoT sensor on a whole bunch of machines out in the field, and it's just kicking out updates all the time. And a totally different vendor, different business, they know how to install the IoT things, they know what the data actually means, they're part of the science of it. I'm just a lowly like cloud engineer. I give them an endpoint that they can shove their JSON over. Then I want to transform the data, and then again, I gotta drop it someplace else. So, as I'm looking to myself and the rest of the team, I'm like, how are we gonna do this in like cost effective, meets all the criteria? And that's where we come to the power of Nicolas Cage. So this is the 2000s Jerry Bruckheimer produced movie Gone in 60 Seconds. Make some noise if you've seen the movie. Yeah, okay, all right. For those who haven't, it's about Memphis Reigns, a retired car thief. Amazing car thief, never caught. But then his brother's a pretty big bonehead and picked up a bad deal with a mobster who's in town. So then Nicolas Cage's character has to come back to save his little brother. So just like when I walked into that meeting with the stakeholders, I was like, all right, what does business want? Then you hear what all the constraints are, and you're like, business wants what? Memphis thought, yeah, I can help Kip. He's my little brother. I steal cars all the time. What's the big deal? You got to do 50 in a night. No way. No one's doing 50 cars in a single night, and that's the whole plot of the movie. It's like, how can Nicolas Cage steal all these cars in a single night? One car, sure. 10 cars, he could probably do it. He's superhuman at stealing cars. I build pipelines. Sure, we can do pipelines all the time, but what is the real constraint? And how do we make those trade-offs? So Cage, he's facing up against evil mob boss and some cops in the area just to save his brother from himself. So there we go. How do we solve this? Well, when Cage has to pull this off, he needs a crew. Like a good chunk of the movie is a nice montage of building your crew, right? Same thing with cloud architecture. You just got to have a montage of building out your crew. Your crew is that infrastructure. It's like, what are the resources? What are the tools that we're going to use? And how is serverless like a bunch of car thieves? Well, I think it's good to think about like traditional servers are long-running processes. They're monolithic. But with a crew, you have individually responsible single units of work that can process things on their own independently. They don't have to go out all together at the same time. They can take off at different times during the night to steal the car and bring it back independently. that allows you to scale how many cars you're stealing without having to worry about always orchestrating all your thieves together. That's how I treat my cloud crew, all of my microservices and the things that I use from AWS. I put these bullets up in case you're trying to get a job as a cloud architect. These are the things that you can put as like stuff I know about, how to decouple services to avoid downtime. Everything is event-driven. It's the idea that you have a system of stuff that's waiting for an event to happen, and then you just process it after the fact. I love infrastructure as code, runs everything I do, and I think it's a faster dev cycle because I can work with real live endpoints that are in the cloud that are already deployed. And then, of course, abstractions all the way down. I realized, actually, one of the previous talks, Brian talked about just how Netlify works and Vercel. So if you're already deploying on that, you're using AWS without realizing you're using AWS. So let's get into the quick architectures of it. So I have a third-party SaaS. It's going to send a post request to an API gateway that I have. There's a Lambda function attached to that gateway. It's going to take the JSON in, partition it by date to an S3 bucket. And then we meet the first super specialist on our crew, Toby. So Nicolas Cage, Memphis Reigns, he's putting together his crew. Everybody's going around saying what the best thing they can steal is. And then Toby's like, I'm good with computers. He's the youngest of the crew. This is the year 2000. He's like, I'm good with computers. And Memphis is like, what does that even mean? And his friend vouches for him. He's like, he could hack the DMV. And that's what he does. Because it's year 2000. And if you know computers, you can hack the DMV. So Nick Cage is like, great, we can find where all the cars are at. Because that's one of the first problems they have. They have a list of cars they have to steal, but they're not sure where to get them from. So Toby here hacks the DMV and enriches all that information, finds addresses for them. In my architecture, I use this service called Athena. Athena is a serverless SQL query layer that you can put on top of any data that's inside of S3. So because when we ingested the S3 files, those JSON files, we partitioned them by a date, and that date partition represents tables and metadata that Athena and Glue can allow me to query on. So data's just coming straight into the bucket, and then at any time, our analyst can run an ad hoc query to match whatever's in the bucket. So Toby here, Athena, enriches our data, enhances it, kind of like hacks into it, and makes it better, makes it usable. So that's how we're filtering the data. Now, the other side, once Athena has filtered the data that we want, it does a little bit of a transformation. In my example code, we go from Fahrenheit to Celsius, and then it puts that data onto this thing called an SQS queue. It's a message bus, it's a queue. Messages come onto it, and then messages go off of it. Now, in the stealing of cars, while Nick Cage and all of the rest of his friends are out taking cars, they're radioing back into Otto. Otto's the old guy. He knows what's up. He's really handling the list from the global perspective. You know, if each thief could have their own list that they have to complete, but then each thief is not really decoupled anymore, right? Their only job is to go out and get the car that they've been told to get. They shouldn't have to know if that car was on the master, like as part of the master list or has already gotten it. That's Otto's job. He's back at base with the actual master list. So SQS is a way for me to handle the upcoming constraint of having to send this data and store it in an external data warehouse, right? It's outside of my network. So I don't want to overwhelm it, so I want to be able to batch it and throttle it before it leaves the queue. And then the queue is there to also make sure that we don't drop messages. One of the features of SQS is that they call it a durable queue, which means you're going to get everything at least once. And it's up to you to implement how you want to handle like deduping or errors when you push it. But in this example, this batch process, it's just constantly listening for messages that go onto the queue. So this Lambda here, I don't ever really have to invoke manually. So now what we can see is that we've taken in some data, found a way to filter it, found a way to batch it to its destination. And this whole time, I haven't really stood up a database at all. I've just been using an S3 bucket and some clever services on top of it because the system that we were building didn't need a permanent database. Like a lot of this data that's always being generated, most of it is within normal operating ranges. So we didn't have to capture everything and save it forever. They were just interested in the ones that hit their criteria at that Athena query layer. And another thing to note about Athena is it's really good at querying. So you can search over stuff that you've set up, but it's not, again, it's not a real database. So you're not like updating values or writing back into S3 with it. It's mainly just for looking at a whole bunch of data and then being able to query on it with SQL without having to instantiate another machine or create a Kafka cluster or anything. It just comes natively from AWS when you how to do this stack. All right, 13 minutes. Whew, this is a good one. So first, I'm gonna ask y'all, do you believe in the power of Cage? Yes, good, okay. Because now I'm about to tell you who I am. My name is Paul Chin Jr. I'm a solutions architect. I'm a solutions architect for Serverless Guru. We are experts in the cloud. We've actually got this really cool thing going where like, if you wanna have an engagement with us, we guarantee that we'll save you money on the cloud engagement or like we won't charge you for it. So I think that's pretty cool. Just saying, just putting it out there. I also run the podcast. If you go to Serverless Guru blog, I got a bunch of cool content there. Do I have time? I got time. And then I've also got to tell you, on the internet, I have a project where I took a salad spinner and turned it into a DJ controller using nothing but JavaScript and WebSockets. That's another different talk. You can come find me afterwards, after we're done here. I got this stuff for days, folks. Like, this is all my brain does. So yeah, you can also find the code repo there. So this is the one slide I'm hoping you're looking at. Yeah, I know. Like, it's really good. I like this. This is an AI picture that I had made, but it was like handcrafted. Like, this is before because I did it like a million times. I was like, shit, I got 5 fingers. I'm done. I know, but it's only 5, bro. Like, I gotta get it where I can. Okay, so demo time on 3. I want to hear the loudest praise Cage ever on 3. 1, 2, 3. Praise Cage. That's right. Let's go. Okay, running in production. So now, all right. So this is an HTTP client. It's called Hopscotch. It's like Postman but better. We're going to send a post request to the API gateway. Everybody with me there? No tricks up my sleeve. Here we go. And sending some JSON data. Whew, here we go. Wrote 6 records to S3. Sick. Let's go to S3. This is a bucket. This is your bucket on AWS. This is your bucket on AWS that just caught some JSON data. All right. Whew, first part's done. That's it. And then the second part is the Athena query function. So anytime I want, I just make this ad hoc. And I'm using the Lambda console here just for simplicity, but you could imagine this trigger being something from the front end, like you build a React app, and the analysts are gonna pass in all of their favorite things to filter through, and you hook it up and you invoke this Lambda, and the Lambda will run its logic, put the thing on the queue, and then once something is on the queue, another Lambda will automatically pull it off and post it somewhere else. So here we go. 1 button click, bang, we're gonna hit test. It's executing. The Lambda is running. It's asking Athena for stuff. All right, so something succeeded, but we can also look here. This is X-ray. It's like a trace map for the functions and services that run in AWS. So let's refresh it and see what it sees. Okay, so this was the post request that came in to our API gateway and wrote some stuff to S3, which is in here. So we're looking at the S3 bucket. All right, I got a transformed, which means that the Athena function should now have run. Yes, here. So when I manually triggered the function, it kicked off this, which then kicked off Athena, which then put the results onto SQS, which then caused another Lambda to post some data to this endpoint. And if I select star, should be 6 records in there. Hey, we did it. That's a full round trip. Hey, 6 records. I'll take it. And so, yeah, I can prove that it went through the system with traces and everything, and all the code is kind of natively done for AWS. But I wanted to show off Valtown. I talk about it a lot because I really love it. It's called val.town. You write TypeScript or JavaScript into it, and the entire external data warehouse endpoint is this file, main.tsx. Valtown has the ability to associate with a SQLite instance in Valtown. So this endpoint is just hooked up to a SQLite, which is, it gives me an endpoint like this, right? And then that's what I post from AWS. So it actually leaves the AWS network and comes into this network and gets written. So with this kind of setup, you can play with you could on purpose make this slower and then start sending stuff and figure out the right batching window you want. Because in SQS, you can batch up to 10 messages at once, and then there's a timeout window. So depending on how long your thing takes to process, you can actually extend the batching timing window from like a minute to maybe 3 minutes. And in those 3 minutes, you'll be able to process the full 10 records. But yeah, Valtown's really great for creating these endpoints. They also have cron jobs that are really fun to use. But basically, once I write it into here, then I'm just able to see the data again. So that was pretty cool. And we went through it like crazy fast. Dang, I went way too fast. All right, so here we go. It is data gone in 60 seconds. This is also, maybe I can give you all some time back. No, running in production. So this is the full architecture. I have, the third party coming into API gateway. As soon as that gateway endpoint is hit with that post request, a Lambda runs, shoves it in the S3 bucket. There is work to have to provision the glue thing. Maybe I can talk about that for like half a second. Athena is a service that enables SQL queries on a metadata catalog that AWS uses called Glue. So before you can use Athena, you have to tell it like what data it's expecting, because you're writing a SQL query. So you have to kind of make up a table, and you have to map your data to something relational that you can query on. So when you're receiving this data, it'll be your job to try to figure out like, how am I going to put these into S3 that I can query on, and how will I map that to the metadata store in AWS Glue so that Athena can do its thing. In my example code repo, there is instructions on the Athena part, the Athena setup, right? This looks a lot like SQL stuff because that's what it is. You have to do this part after you deploy so that you can set up Athena, but once it's set up, it is like a database, but it's not a database. It's some fun software middleware that allows you to treat these persistent S3 objects like a database, which I think is pretty cool, because at no point during the time of this build did I ever have to stand up a real database. All of my IAM and access and stuff was just through service roles. So the worst thing I hate about databases is that one moment where you have to have the master account. It's like database name, password, and that is somewhere. It can't be nowhere. It is somewhere, and that always keeps me up at night. But with IAM roles, they're just always ephemeral. They're checking in with the master, or they're checking in with the main service at runtime every single time. Way more secure. Way more secure. All right, and I guess while I'm in here, I could show you the SAM template. Make some noise if you know what SAM is. Okay, SAM is, you go watch his talk, because it'll actually do a really good job of explaining how to use AWS without AWS. And so SAM is a infrastructure as code tool that will turn this YAML into much larger CloudFormation. But the entire app that I'm showing, the entire pipeline that I have here is defined as a bucket, the API endpoint, an API key, so it's authenticated, some accounting on that API key so that you can charge people for it, the actual data queue, the actual functions right there and there and there. So there's only 3 functions of code that I've written to do this whole thing. And when you deploy it, it deploys all this stuff for you. And a lot of it fits in the free tier. So even on AWS, if you're just playing around with it, you can do some decent stuff with just this. So let's go back to this final diagram, right? We got Toby the hacker. He's enriching the data. The crew is capturing the stuff, and then Otto's making sure that all the things are being checked off. And it's pretty much automated. Like, if I wanted to, I could script just like posting to the endpoint and then script the Athena client running on its own. I really don't have to do much of anything else. So for those that aren't like in AWS, there's ways to do all of this stuff in every other cloud. This is just, the idea is to not have to be precious about the underlying infrastructure specifically. Like, I don't really want to have to put together my own Kafka instances to handle messages. I really don't want to have to deal with like hard disk file IO if I can help it. And that's really what it means to kind of like build cloud native, build serverlessly. It's about finding that value from the vendor so that you can just worry about stealing the cars, like converting the data to a format that you want. And by doing this with the infrastructure as code, like you can put it all in a CI/CD pipeline, you can deploy the front end and the back end all at the same time. Super cool, super clutch. It's the only way I've been building stuff in the cloud for the last 8 years. And so finally, with 2 minutes and 35 seconds left, did we learn something? Ah, yes, very good, very good. So I like to break up my talks into 3 different sections. For those that are brand new to this stuff, speed. There's from that QR code, there's a repo. Download the repo. Try to use it. It should run. If it doesn't, file me a ticket. You'll learn how to do pull requests. It's a win-win for everybody. If you're kind of intermediate, there's a lot of stuff you might be able to break or figure out how to start from my repo as a starting point and see if you could make it more secure, or if there are something about it that you could change to make it even better. And then finally, for those that have been doing this for quite a while, I implore you to add narrative to your architectures. Like, I go into the room and I say, hey, we gotta fight these bad guys, man. Like, people can come together. Like, I got the cops breathing down my neck. I got these mob bosses on me. And everyone's gonna kind of know, that there's something more going on than just the code. And I think I've heard it from all the folks out in the vendor areas where I'm like, hey, what are you really looking for folks that are coming onto your team? And a couple of them said, like, we need people that can understand the business as well as the code, even more so the business. So if you're able to explain your code with narratives like this, it goes a really long way to be able to like get that political capital for you and your team. And finally, if you don't know what ADR is, it's an architectural decision record. It's like 2 sentences of why you did it. It's not a commit message. It's not a comment. It's an actual reason why you did something and why you didn't do something else. Just check it in with the repo. Those 2 sentences will save somebody 4 hours in 6 months. Promise you, if you start doing them regularly, you will be the 10x engineer. And with that, thank you so much. I got 40 seconds left. Yeah! And then for promo on my next talk, Better the Devil I Know sequel, a Ghostwriter vengeance story where two database paradigms battle it out for my soul. And with that, thank you all for being here. I really appreciate you taking the time. Let the conference know how everything was. Make noise on social media. I am Paulchin Jr. everywhere, serverless guru. That's it. Thanks. Yeah! Oh, 5 seconds left. One more praise cage in 3, 2, 1. Praise cage! Done. Bam! Yeah, let's go.